For a quiet evening in Oklahoma, 1953, the air is still, the world is hushed, and overhead, the familiar orb of the moon shines with its steady, ancient light. For Dr. Leon Stewart, an amateur astronomer with a passion for the cosmos, this was a sacred time. He was at his telescope, meticulously adjusting the focus, his eye pressed to the eyepiece, exploring the lunar surface he knew so well. But on this particular night, the moon decided to reveal a secret it had held for eons. Suddenly, a blinding flash erupted on the dark limb of the moon, a colossal burst of light, visible even through his modest telescope. Dr. Stewart, ever vigilant, quickly aimed his camera, capturing the fleeting spectacle. What he saw, what he believed he saw, was a gigantic fireball, a plume of vaporized rock, a telltale sign of an immense impact. If his intuition was correct, he had just become the first human being to witness and document a lunar impact event. It was a momentous observation, an extraordinary claim that would soon become known simply as Stewart's event. For Dr. Stewart, the photograph was undeniable proof. For the scientific community, however, it presented a baffling enigma. While the image clearly showed something had happened on the moon in 1953, finding the resultant crater proved to be an impossible task for decades. As space exploration advanced, as astronauts walked on the moon, and as sophisticated space probes mapped its every curve, Stewart's event remained a historical curiosity, a photograph with no definitive accompanying scar. No one, despite extensive searches, could pinpoint the crater left by such a monumental explosion. Was it a trick of light, a photographic anomaly? The mystery persisted, a testament to the fleeting nature of the event and the vastness of the lunar surface. Yet, that single, grainy photograph, a silent sentinel from 1953, continued to intrigue. It refused to be dismissed. For half a century, it whispered of a Titanic event, an unseen force that had momentarily scarred our closest celestial neighbor. The problem wasn't the event itself, but rather the sheer scale of the lunar landscape and the limitations of early observational techniques. It takes a remarkable level of precision to find a specific impact site on a body as large and scarred as the moon, even one born from such immense energy. Then, in 2003, exactly 50 years after Dr. Stewart's incredible observation, a team of NASA researchers decided to revisit the enduring puzzle. They weren't starting from scratch, but rather with a crucial piece of evidence, Stewart's original photograph. Their approach was methodical, leveraging the advancements in technology that simply weren't available in 1953. They meticulously analyzed the image, using sophisticated computational models to reverse engineer the event. Based on the size and brightness of the fireball captured by Dr. Stewart, they calculated that the impact would have left a remarkably fresh crater, measuring up to 1.24 miles, or 2 kilometers across. This calculation provided a vital clue, a specific size range to look for. Armed with this estimate, and taking cues from the subtle features of the lunar landscape visible in the famous photograph, the team narrowed down their search area, focusing on a grid roughly 22 miles or 35 kilometers across. The tools for their renewed quest: high-resolution images of the moon taken in 1994 by the Lunar Orbit and Clementine spacecraft. This probe had meticulously mapped the lunar surface, providing an unprecedented level of detail. The search was painstaking, involving countless hours poring over digital images, searching for that one telltale circular depression that matched their calculations. It was a search for a needle in a cosmic haystack, guided by the ghost of a flash from 5 decades prior. And then, incredibly, against all odds, they found it. A fresh-looking crater, undeniably new in appearance compared to its ancient surroundings, sat nestled right in the middle of where Dr. Stewart's photograph indicated. It measured 0.93 miles, or 1.5 kilometers across, slightly smaller than their initial maximum estimate, but perfectly within the expected range for the energy released. The characteristics were a perfect match: its fresh appearance, its distinct morphology, and crucially, its precise location. This discovery was monumental. It wasn't just about finding a hole in the moon, it was validating a pioneering observation made by an amateur astronomer half a century earlier. The estimated energy output of that impact, derived from the size of the crater, was staggering, 35 times stronger than the atomic bomb that had devastated Hiroshima. It was a truly titanic event, witnessed and documented, and then, after 50 years of patient scientific pursuit, finally confirmed. Stewart's event wasn't just a fleeting flash in the night sky. It was a powerful reminder of the dynamic nature of our solar system, of the constant bombardment that shapes planetary surfaces even today. It stands as a testament to the enduring power of observation, the meticulous nature of scientific inquiry, and the incredible journey from a single grainy photograph taken by an amateur to a definitive confirmation by advanced space technology. It's a story of perseverance, of patience, and of a mystery patiently waiting for the right tools and the right minds to finally unveil its truth. What are your thoughts on this incredible 50-year journey to confirm a single moment in time? Have you ever had a similar experience of a long unanswered question finally finding its resolution? Share your insights in the comments below. And if you found this story as fascinating as we did, please consider liking this video and subscribing for more journeys into the untold stories of science and discovery.